Hey guys, today we're going to learn how to do some vector addition. Vector addition is a pretty easy way to solve. You can use it to apply with forces and other things. Basically, what we're trying to do is find out with all these different magnitudes and angles what will result from this. So the question reads, in the diagram below, vector A has a magnitude of 12.5 above the horizontal by 37 degrees. Vector B has a magnitude of 9.3, 61 degrees below the horizontal. And vector C has a magnitude of 6.1, 10 degrees above the negative horizontal. And just by the way, the horizontal is your x-axis, and so to say it's 37 degrees above means it's 37 degrees above the x-axis, and the negative horizontal only means that it's on the negative x side of the xy plane. So, using this, we need to find the resultant vector in polar coordinates and unit vector notation. It doesn't mean we have to do two different calculations, that just means they want the answer in two different forms. So to start off, what we're going to do is find the components of each vector. And so to do this, we need to create triangles with all three of these, and using some basic trigonometry functions, we can figure out what the x and y distances are for each one. So we'll start off with vector A. And so for vector A, in the x direction, to calculate this, we will use 12.5, which is your hypotenuse, cosine, because remember cosine will give you the adjacent over the hypotenuse, and we use the angle 37 degrees. So that will give us our x component of vector A, which if you do your calculations should equal 9.98 I hat, and I hat just means that it is in the x direction. And for the y component, to find that, we do 12.5 sine 37, and sine is, if you remember, opposite over hypotenuse, and if you do that calculation, you get 7.52 j hat, and j hat is the y axis. So for A we have 9.98 I hat plus 7.52 j hat. You can just set that aside for now, and we do vector B. And to find vector B, we're going to do 9.3, which is your hypotenuse again, and to find the adjacent angle, or the adjacent side, you use cosine, and your angle 61. And since it's negative this time on the y-axis, we want to do minus instead of positive, because if you think about it, to have both positives, that means it's positive I and positive j, and this time it's positive I, but negative j, because it goes below. So you get minus 9.3 sine 61, and if you do these calculations, you should get 4.51 I hat minus 8.13 j hat. And now for C, since we have a negative x direction, we're going to do negative 6.1 cosine 10, and since it goes positive, we have positive or plus 6.1 sine 10. You do these calculations, you should get negative 6.00 I hat and positive 1.06 j hat. Okay, now you have the components of all three vectors, and so you're probably wondering, what are we going to do next? So next we are going to get all the components in the x direction, or the I hats, and add them all up. So for the resultant vector in the I hat direction, we get 9.98 plus, because you have another positive, 4.51, and since the last one's negative, you subtract 6.00, and that should get you 8.49 in the I hat direction. And for your j hat components, you add 7.52. Your next one's negative, so you do minus 8.13. Another positive, 1.06. You do that calculation, and you get 0.45 positive j hat. Okay, So now you have the I hat and j hat component of your resultant vector, and that happens to be the polar coordinates of the resultant vector. So to answer in polar coordinates, you can put it as a ordered pair, and just like an ordered pair, the x comes first, which would be 8.49, comma, then comes your y, 0.45. There you go. There you have polar coordinates. And next we are going to try to solve unit vector notation from that. Okay, to find your unit vector notation, what you're going to want to do is make another triangle. Obviously, this is not to scale. And so you have, from your polar coordinates, two positive components. And for the x, we can take 8.49. And for the y, we have 0.45. And what we're trying to find is sigma, which is the angle in which the resultant vector will be compared to the horizontal. And so to find this, you can use another trigonometry function. You can use inverse tangent, which on your calculator is second tangent, and you have opposite over adjacent, so you're going to do 0.45 over 8.49. You do that calculation for your sigma, you should get 3.034 degrees, which makes sense because the x value is much larger than the y value. You can't really tell in this triangle because it's not to scale, but if you were to draw this out, it would probably look a lot more like that. So it makes sense that your sigma angle is so small. And so you're going to save that. And to find the magnitude of your resultant vector, you're going to use Pythagorean's theorem, which you've probably used before. And you take the two legs of the triangle to get your hypotenuse, which is h. H squared equals 8.49 squared plus 0.45 squared. And if you were to have negative components, actually, this wouldn't really matter because you're squaring it. So say we had negative 8.49, if you square it, you'll get the same thing as if you were to square positive 8.49. And so you do that calculation, you should get h squared equals 72.28, bunch of other numbers. You keep that in your calculator right now, and we can just automatically square your answer on a calculator, which shouldn't be too hard. And if you do that, or excuse me, not square root it, and if you do that, you should get 8.501. So there's your magnitude of your resultant vector. And to put this into unit vector notation, you are going to describe the magnitude of your resultant vector, which will be 8.501, and then you do the angle in which the resultant vector goes relative to the horizontal. And so in this case, we have positive 3.04 degrees. So you're going to say 8.501 at 3.034 degrees above the horizontal, which I probably can't fit. So above the horizontal. And there you go. This is pretty universally applicable, so I mean, it's not going to be too different no matter what your magnitudes or your angles are going to be. Every time you just want to break it down into its components, which you do by using those trig functions. Once you've broken down all three of them, or two if you have two, or four, however many you need, what you're going to do is you're going to add them together, and then you'll get your component of the resultant vector. And you do the same for the j hats, and you'll get the y component. And then from there, you can use your Pythagorean theorem and some more trigonometry functions, and you can figure out what to do. And that's it. Thank you.